मीट तो मेरे। हेलो।
मस्त गाने के लिए वोट आप
Bamboo and rattan, pride of nature, friend of mankind. With the aim to protect, cultivate, and exploit the world's bamboo and rattan resources. The International Bamboo and Rattan Organization, INBAR, was established in 1997. INBAR is the first intergovernmental organization to host its headquarters in China, and remains the only one to focus on promoting bamboo and rattan for sustainable development. INBAR's mission is to improve the well-being of producers and users of bamboo and rattan by consolidating, coordinating, and supporting strategic and adaptive research and development. Over the last 2 decades, INBAR has grown steadily, and in April 2019, reached 45 member states. Our member states are spread across Africa, Asia, Oceania, and the Americas. INBAR has regional offices in Cameroon, Ecuador, Ethiopia, Ghana, and India. To realize its mission, INBAR is active across different fields, such as environmental protection, poverty alleviation, and livelihood development. INBAR supports scientific and technological innovation, the cultivation and expansion of existing resources, downstream processing and utilization, and the promotion and use of a wide variety of diversified products, as well as showcasing the positive contribution to the development of a green economy, poverty alleviation, and livelihood improvement. Cultural products and heritage can enhance quality of life and protect, enhance, and expand bamboo and rattan culture. INBAR is an observer to the United Nations General Assembly and has recently achieved great success during its 20th anniversary celebrations and 2018's Global Bamboo and Rattan Congress. Heads of state from China, Ethiopia, Ecuador, Colombia, Cameroon, and Madagascar, as well as heads of high-level agencies of the United Nations, expressed support for these events in different forms or congratulated INBAR for its increasing international visibility and influence. Looking towards the future, INBAR has formulated a development plan for 2015 to 2030. We will work with member states and international partners to help achieve the UN 2030 Agenda for Sustainable Development and align with plans for the Belt and Road Initiative and South-South cooperation. INBAR will forge a unique path to make a real positive difference and work together towards a more equitable and greener world.
Warm greetings from UIA. I am José Luis Cortés, President of the International Union of Architects. For the last 73 years, the UIA alone has represented the world's architects, now estimated to around 3.2 million. The UIA unites architects from more than 100 countries and territories by the strength of diversity and partnership across the 5 regions of the UIA. At the COP21-24, when the UIA made calls in action to halt climate change, governments, civil society, and the private sector have recognized that the built environment is a contributor to climate change. UN declared year 2021 as the Climate Action Year. We have to implement climate action for cities in terms of climate adaptation, mitigation, and response. Coupled with the pandemic situation, we are examining closely the immediate and pressing future of our built environment and human settlements. By 2030, we have to implement the Sustainable Development Goals. To achieve changes in next 8 years is a global challenge. In recognition of the urgency of the situation, the UIA has formed an independent commission on sustainable development goals named UIA SDG Commission to influence architects towards sustainable, resilient, climate-friendly, and carbon-neutral design. To facilitate the challenge, we accept UN Habitat's new urban agenda as our own, and we endorse United Nations 17 Sustainable Development Goals, and we pledge to achieve carbon neutrality in our communities and buildings. The UIA acknowledges the efforts of all stakeholders of built environment to make change. Similarly, governments, civil society, researchers, and the private sector can help secure public demand for sustainable solutions and investment. To initiate new solutions, we have to explore new partnerships. For this, we look to INBAR, with its expertise assisting governments, businesses, and local communities to identify new and innovative uses for bamboo and rattan as a building material across more than 50 countries in global South Asia, Africa, and Latin America. The UIA is delighted to work with INBAR to promote resilient design through sharing the design ideas of bamboo architecture. Lastly, on the occasion of the COP26, I pledge to the architects of the world to acknowledge that using the time-tested traditional technology, innovative ideas, and in the passive implementation process, there is a window of opportunity to shape our built environment and the cities in a way that reduces overall energy consumption and greenhouse gas emissions. Thank you very much.
Bamboo and rattan, pride of nature, friend of mankind. With the aim to protect, cultivate, and exploit the world's bamboo and rattan resources, the International Bamboo and Rattan Organization, INBAR, was established in 1997. INBAR is the first intergovernmental organization to host its headquarters in China, and remains the only one to focus on promoting bamboo and rattan for sustainable development. INBAR's mission is to improve the well-being of producers and users of bamboo and rattan by consolidating, coordinating, and supporting strategic and adaptive research and development. Over the last 2 decades, INBAR has grown steadily, and in April 2019, reached 45 member states. Our member states are spread across Africa, Asia, Oceania, and the Americas. INBAR has regional offices in Cameroon, Ecuador, Ethiopia, Ghana, and India. To realize its mission, INBAR is active across different fields, such as environmental protection, poverty alleviation, and livelihood development. INBAR supports scientific and technological innovation, the cultivation and expansion of existing resources, downstream processing and utilization, and the promotion and use of a wide variety of diversified products, as well as showcasing the positive contribution to the development of a green economy, poverty alleviation, and livelihood improvement. Cultural products and heritage can enhance quality of life and protect, enhance, and expand bamboo and rattan culture. INBAR is an observer to the United Nations General Assembly and has recently achieved great success during its 20th anniversary celebrations and 2018's Global Bamboo and Rattan Congress. Heads of state from China, Ethiopia, Ecuador, Colombia, Cameroon, and Madagascar, as well as heads of high-level agencies of the United Nations, expressed support for these events in different forms or congratulated INBAR for its increasing international visibility and influence. Looking towards the future, INBAR has formulated a development plan for 2015 to 2030. We will work with member states and international partners to help achieve the UN 2030 Agenda for Sustainable Development and align with plans for the Belt and Road Initiative and South-South cooperation. INBAR will forge a unique path to make a real positive difference and work together towards a more equitable and greener world.
Warm greetings from UIA. I am José Luis Cortés, President of the International Union of Architects. For the last 73 years, the UIA alone has represented the world's architects, now estimated to around 3.2 million. The UIA unites architects from more than 100 countries and territories by the strength of diversity and partnership across the 5 regions of the UIA. At the COP21-24, when the UIA made calls in action to halt climate change, governments, civil society, and the private sector have recognized that the built environment is a contributor to climate change. UN declared year 2021 as the Climate Action Year. We have to implement climate action for cities in terms of climate adaptation, mitigation, and response. Coupled with the pandemic situation, we are examining closely the immediate and pressing future of our built environment and human settlements. By 2030, we have to implement the Sustainable Development Goals. To achieve changes in next 8 years is a global challenge. In recognition of the urgency of the situation, the UIA has formed an independent commission on sustainable development goals named UIA SDG Commission to influence architects towards sustainable, resilient, climate-friendly, and carbon-neutral design. To facilitate the challenge, we accept UN Habitat's new urban agenda as our own, and we endorse United Nations 17 Sustainable Development Goals, and we pledge to achieve carbon neutrality in our communities and buildings. The UIA acknowledges the efforts of all stakeholders of built environment to make change. Similarly, governments, civil society, researchers, and the private sector can help secure public demand for sustainable solutions and investment. To initiate new solutions, we have to explore new partnerships. For this, we look to INBAR, with its expertise assisting governments, businesses, and local communities to identify new and innovative uses for bamboo and rattan as a building material across more than 50 countries in global South Asia, Africa, and Latin America. The UIA is delighted to work with INBAR to promote resilient design through sharing the design ideas of bamboo architecture. Lastly, on the occasion of the COP26, I pledge to the architects of the world to acknowledge that using the time-tested traditional technology, innovative ideas, and in the passive implementation process, there is a window of opportunity to shape our built environment and the cities in a way that reduces overall energy consumption and greenhouse gas emissions. Thank you very much.
Bamboo and rattan, pride of nature, friend of mankind. With the aim to protect, cultivate, and exploit the world's bamboo and rattan resources, the International Bamboo and Rattan Organization, INBAR, was established in 1997. INBAR is the first intergovernmental organization to host its headquarters in China, and remains the only one to focus on promoting bamboo and rattan for sustainable development. INBAR's mission is to improve the well-being of producers and users of bamboo and rattan by consolidating, coordinating, and supporting strategic and adaptive research and development. Over the last 2 decades, INBAR has grown steadily, and in April 2019, reached 45 member states. Our member states are spread across Africa, Asia, Oceania, and the Americas. INBAR regional offices in Cameroon, Ecuador, Ethiopia, Ghana, and India. To realize its mission, INBAR is active across different fields, such as environmental protection, poverty alleviation, and livelihood development. INBAR supports scientific and technological innovation, the cultivation and expansion of existing resources, downstream processing and utilization, and the promotion and use of a wide variety of diversified products, as well as showcasing the positive contribution to the development of a green economy, poverty alleviation, and livelihood improvement. Cultural products and heritage can enhance quality of life and protect, enhance, and expand bamboo and rattan culture. INBAR is an observer to the United Nations General Assembly and has recently achieved great success during its 20th anniversary celebrations and 2018's Global Bamboo and Rattan Congress. Heads of state from China, Ethiopia, Ecuador, Colombia, Cameroon, and Madagascar, as well as heads of high-level agencies of the United Nations, expressed support for these events in different forms or congratulated INBAR for its increasing international visibility and influence. Looking towards the future, INBAR has formulated a development plan for 2015 to 2030. We will work with member states and international partners to help achieve the UN 2030 Agenda for Sustainable Development and align with plans for the Belt and Road Initiative and South-South cooperation. INBAR will forge a unique path to make a real positive difference and work together towards a more equitable and greener world.
Warm greetings from UIA. I am José Luis Cortés, President of the International Union of Architects. For the last 73 years, the UIA alone has represented the world's architects, now estimated to around 3.2 million. The UIA unites architects from more than 100 countries and territories by the strength of diversity and partnership across the 5 regions of the UIA. At the COP21-24, when the UIA made calls in action to halt climate change, governments, civil society, and the private sector have recognized that the built environment is a contributor to climate change. UN declared year 2021 as the Climate Action Year. We have to implement climate action for cities in terms of climate adaptation, mitigation, and response. Coupled with the pandemic situation, we are examining closely the immediate and pressing future of our built environment and human settlements. By 2030, we have to implement the Sustainable Development Goals. To achieve changes in next 8 years is a global challenge. In recognition of the urgency of the situation, the UIA has formed an independent commission on sustainable development goals named UIA SDG Commission to influence architects towards sustainable, resilient, climate-friendly, and carbon-neutral design. To facilitate the challenge, we accept UN Habitat's new urban agenda as our own, and we endorse United Nations 17 Sustainable Development Goals, and we pledge to achieve carbon neutrality in our communities and buildings. The UIA acknowledges the efforts of all stakeholders of built environment to make change. Similarly, governments, civil society, researchers, and the private sector can help secure public demand for sustainable solutions and investment. To initiate new solutions, we have to explore new partnerships. For this, we look to INBAR, with its expertise assisting governments, businesses, and local communities to identify new and innovative uses for bamboo and rattan as a building material across more than 50 countries in global South Asia, Africa, and Latin America. The UIA is delighted to work with INBAR to promote resilient design through sharing the design ideas of bamboo architecture. Lastly, on the occasion of the COP26, I pledge to the architects of the world to acknowledge that using the time-tested traditional technology, innovative ideas, and in the passive implementation process, there is a window of opportunity to shape our built environment and the cities in a way that reduces overall energy consumption and greenhouse gas emissions. Thank you very much.
Ladies and gentlemen, our meeting will be started in 5 minutes. So I would like to remind all the participants to mute your microphone and keep silent during it in the chat box. Thank you. Program and the International Bamboo and Rattan Organization. The seminar is co-organized Union of Architects, the School of Civil Engineering of Tsinghua University, the School of Architecture of Tsinghua University, Architecture Design and Research Institute of Tsinghua University, with the supporting from other 12 international institutions around the world. In this month, we will invite 19 experts to present their experience on bamboo construction to all of you. The organizing committee would like to extend our gratitude to your attendance at the opening as well as the first session of the seminar. Firstly, let me introduce our distinguished guests. Professor when I introduce your name, please kindly open your microphone and say hello to everyone. Professor Lu Wenming, Deputy Director General of INBAR. Professor Lu.
Hello. Good day and good evening in China and good day in some other areas. Thank you very much for joining our online seminar about the construction of bamboo. And I would like to extend our gratitude and appreciation to our partners, the International Union of Architects and also several organizations in Tsinghua University, especially for all participants. I just say that there are right now, there are 170 participants and maybe some more is coming. So it could be 200 people. So I wish that tonight or today's seminar a great success. Thank you very much.
Thank you, Professor Lu. I will introduce Mr. Ishtiaque, Zahir Titas, Co-Director of UIA Commission for Sustainable Development Goal, Vice President of UIA Region 4. Ishtiaque?
Thank you. Can you hear me?
Yes.
Okay. Good morning, good afternoon, and good evening to all of the world. I'm Architect Ishtiaque, the Vice President and also the Co-Director of SDG Commission. We are very delighted to have this collaboration with INBAR because UIA unites architects of the world with the strength of diversity and partnership. And this is how we have formed our work commission and also SDG Commission. And this SDG Commission has reached out many members like UN Habitat, UNESCO, Landscape Architects, World Urban Campaign, and UNFP. And now we have got a new partner that is INBAR. And with INBAR, we will move forward with more diversity. And tomorrow, in collaboration with INBAR, we are having a program in COP26. I'm at the moment in COP26 venue, and we'll initiate the dialogue of global architects, engineers. How can we integrate carbon neutrality into the built environment design process? And it will encompass the climate-friendly, resilient design and the construction process with bamboo, its life cycle analysis, standards, and engineered bamboo architecture. So to me, it's like, I would like to say that the built environment professional from diverse regions of the world needs to discuss what are the means to achieve the emission reduction milestone of 2050 through introducing climate sensitive design solutions like bamboo in the built environment. And we acknowledge that designing built environment with bio-friendly material and the construction process will protect our ecosystem. I welcome all the speakers for the next couple of days. There will be a lot of session, and we are very delighted from United International Union of Architects. We are happy to be engaged into this discourse. Thank you very much.
Thanks a lot, Ishtiaque. Actually, we arranged 4 more sessions for all the speakers to deliver 4 more speeches. So you just say hello to everyone. Then the next one is Professor Zhang Li, Dean of the School of Architecture at Tsinghua University, because Zhang Li received an urgent task today, and he is still in another important national project. So he sent us a video speech. So later we will show up his speech. Next professor is Ken Harris, member of INBAR Bamboo Construction Task Force, professor of University of Pittsburgh. So Ken, please say hello to everyone.
Good morning, good afternoon. Do you want me to introduce what's going on, or do you just want me to say hello?
Just say hello. Show
just
up.
Say hello. Hello, everybody. Happy you know me already.
Okay, so next speaker is Mr. Jakob Brandtberg, Knudsen, Dean of Architecture of Royal Danish Academy, Architecture, Design, and Conservation. Hi, Jakob.
Hello, thank you. Do I do my presentation now, or should I just say hello?
No, just say hello, show up to all the participants.
And thank you for inviting me. It's a very interesting subject, which is close to my heart. So I'm looking forward to a very interesting afternoon / evening / morning, wherever you are in the world. Thank you.
Okay, thanks, Jakob. Let's welcome Professor Song Yehao, School of Architecture at Tsinghua University, Vice Principal of Architecture Design and Research Institute of Tsinghua University, co-founder and principal of SOUP Atelier. Welcome,
hello,
Professor Song.
Hello. Yeah, it's a great honor to be here to with you again. And thank you very much for the kind and very great efforts for organizing this kind of conference. Thank you very much. Great honor here.
Okay, thanks, Professor Song. Let's welcome Neil Thomas, founder and director of Atelier 1. Neil.
Hello. Hello,
Hi.
can you hear me? Hello, everybody.
Yes.
Thank you very much for inviting me. It's very exciting. I'm also very excited to see what's going to happen over the next couple of days. And I look forward to talking to you all a little later. I hope everybody enjoys this.
Okay, thanks, Mayor. There are also several speakers and moderators of next 4 sessions, whom I will not name individually. Welcome you all. Dear participants, now let's welcome Professor Lu Wenming, DDG of INBAR, to deliver the speech. Due to Professor Lu's planned duty travel, so he prepared a very formal video speech for the seminar. Also, he canceled his duty travel, but we still want to show up his video. So please, Qinhui.
Your Excellencies, Mr. Ishtiaque Zahir Titas, Professor Yongjiu, Professor Zhang and Professor Kent Harris, distinguished speakers, ladies and gentlemen, warm greetings from Beijing. I'm honored and delighted to deliver the opening speech for the 2021 International Online Seminar, Bamboo, a very sustainable construction material. Based on the great success of INBAR's online webinar series last year and the current situation, which makes it difficult to carry out effective international exchange in person, we have selected some themes for further discussion this year. Bamboo construction has always been a key development direction supported by INBAR. It can provide a nature-based solutions to global housing storages and support sustainable livelihood development, climate change mitigation, and the goal of carbon neutrality. There's huge potential for bamboo construction, but still a significant lack of awareness and technical expertise to scale up its use. I'm proud to note that this year's INBAR seminar has the full support of 16 other institutions. I would like to extend my gratitude to the International Union of Architects, the School of Civil Engineering of Tsinghua University, the School of Architecture of Tsinghua University, and the Architecture Design and Research Institute of Tsinghua University for co-organizing this construction webinar series with INBAR. Their support and the support of all other institutes, universities, and journals is recognized with gratitude. We also welcome distinguished representatives from these institutes to deliver their opinions on how to use bamboo to solve our current global challenges. Over the course of 5 sessions this year, we will invite 19 senior experts from around the world to share the latest developments in bamboo construction. Half of them are from the INBAR.
So there are some problems for Professor Lu's video speech. Qinhui. So maybe
sorry, I will reopen the video. Just wait a second.
So welcome all the participants from around the world. This year, we received totally more than 700 registration information from around 70 countries. So welcome you all to support INBAR and love bamboo construction. So if there's still some kind of the problem, we will go to the next session. INBAR really appreciates the efforts made by our 16. Okay, to please video.
Your Excellencies, Mr. Ishtiaque Zahir Titas, Professor Yongjiu, Professor Zhang and Professor Kent Harris, distinguished speakers, ladies and gentlemen, warm greetings from Beijing. I'm honored and delighted to deliver the opening speech for the 2021 International Online Seminar, Bamboo, a very sustainable construction material. Based on the great success of INBAR's online webinar series last year and the current situation, which makes it difficult to carry out effective international exchange in person, we have selected some themes for further discussion this year. Bamboo construction has always been a key development direction supported by INBAR. It can provide nature-based solutions to global housing mitigation and the goal of carbon neutrality. There's huge potential for bamboo construction, but still a significant lack of awareness and technical expertise to scale up its use. I'm proud to note that this year's INBAR seminar has the full support of 16 other institutions. I would like to extend my gratitude to the International Union of Architects, the School of Civil Engineering of Tsinghua University, the School of Architecture of Tsinghua University, and the Architecture Design and Research Institute of Tsinghua University for co-organizing this construction webinar series with INBAR. Their support and the support of all other institutes, universities, and journals use bamboo to solve our current global challenges. Over the course of 5 sessions this year, we will invite 19 speakers, business models, and experiences on capacity building for professionals.
INBAR really appreciates other 16 international institutes to co-organize the seminar with us. So, Ishtiaque, would you like to say something more?
Thank you. I'd just like to add that today cities account for 75% of the world energy consumption and are responsible.
And how could it be kind of looked upon not as a cheap material, but actually a very valuable material where you can make a beautiful things. One of the reasons we are doing is that it is so sustainable. We know that in Africa, the population is growing very fast. It's going to double in the next 30 years from 1.3 to 2.5 or 2.6 billion people. It's much faster than anywhere else in the world. India is still growing a bit, but not at all to the same extent in the next 30 years. The growth in the world is happening in the next 30 years in Africa. So it's really important what we do in Africa. And we can see if promote bamboo, I think it, and you'll find parts of Africa where it's still looking much the same if you go to rural area. But you will also find parts of Africa where they had houses that looked a bit like the typical Asian houses, raised on stilt and built from light material. This knowledge has disappeared in the past 100 years. But there were actually people building very good houses based on the same principle as you found in Asia. And I think there's a chance that you could reintroduce some of these examples. But we need to build, as architects, we need to build examples to demonstrate to people how you can do this. So in these villages where we build these new houses in bamboo and timber and shade net, we also found that people start to copy it. This is a young guy who built next to our bamboo house. So he used what he had of a local material. This is sisal stems. So it's using the same principles as we have done, but he's using his own material. But it's big windows, it's light construction, it's air moving through the house in all directions. So it's a really good example of how people will actually start to take up technology if they just have some examples to learn from. And then, of course, we're talking about Africa, but Africa is a huge place. It's like the size of China, United States, and Europe and India combined. So there will not be one solution. What we are presenting here today is a possibility, but it will not be the same solution for the entire continent. There's a need for many different solutions. And then, of course, I have to say as an architect that buildings are always about identity and aesthetics. So we need to do whatever we do. It needs to be beautiful. It needs to be something that people can relate to. It has to give meaning. Otherwise, people will not buy into it. What we have done has been supported by many different institutions and organizations. So I want to thank all these people, not least the Hanako Foundation from Singapore, who has been supported most of this research. Thank you.
Thanks, Jakob. From your presentation, we saw you really has carried out many practices in Africa. So your presentation also encouraged us how to use bamboo to improve local people's living conditions so that they can get rid of those deadly infectious diseases. And currently, INBAR has 3 regional offices located in Cameroon, Ghana, and Ethiopia. And we also have 20 member states in Africa. So in the near future, we hope we can have more collaboration and work with you.
So do we. Thank you very much.
Thanks. Let's welcome the second speaker, Professor Song Yehao. Is from China. His topic is fish-shaped bamboo pavilion of INBAR Garden and 2021 Yongjiu International Horticulture Expo. Professor Song is an architect, researcher, and educator. He is the co-founder and principal of SOUP Atelier, the director of the Institute of Architecture and Technology and Tsinghua University, and the Secretary General of the Chinese Green Building Committee. Professor Song has been concentrating on sustainable theory and design for over 20 years, while highly promoting the combination of modern design and vernacular architecture in China. For his work, he received awards from all over the world, including the Gold Medal and Arc Asia Award of Architecture, the Engineering Prize of the World Architecture Festival 2019, the Architizer A+ Award, and etc. So welcome, Professor Song.
Okay, thank you, Kewei. Can you hear me?
Yes, very clear.
Can you see the share screen?
Yes.
Yes, okay, I just go on. Thank you very much. It's a great honor to be here to say colleagues and a lot more experts and professors are doing something with bamboo. It is also a great opportunity to share something, and I'm very glad to hear something, kind of feedback from you. Actually, we have not a long history with bamboo, only 4 years, but we do different types of trying, making full use of bamboo. We have kind of principles for bamboo construction, even bamboo as kind of renewable resources, as trees, timber. Still, we think if we can save some bamboo for another building, that might be great. So we are looking for a kind of solution for using less bamboo with larger space construction thing. And we got a great opportunity when we look back to the history, Chinese history. Thousands of years ago, actually, not all the buildings were enveloped. And most of the literature people, they were fond of kind of communication with nature, with open space, only kind of shelter or pavilion, this kind of thing. That's a great part for the buildings at that time, which today we are lack of. So we are trying to find a kind of combination with bamboo building or bamboo architecture with this kind of traditional Chinese vision for the understanding of something related with nature from the minds of literature people. And also we have a kind of understanding that bamboo is a growing resources, one of the resource in China and also in the world, around the world. And also we all quite familiar with the structure thing and with the macro structure thing of bamboo. And also all over the world, we are adopting almost the same methods to joint, to construct, to make the different bamboo together, to join them with ropes, with steel components, or with a lot more things, almost the same all over the world. So what can we do? So we try to do research focusing on use less bamboo with more, just there as kind of architectural principle to do more with less, even with bamboo, this kind of growing renewable resource. And INBAR Pavilion is one of the projects doing adopting this kind of principle. It looks like a fish because fish means something good in the minds of Chinese, means the harvest for the next year, means we have something extra, rich, wealthy, or this kind of meaning. So we just blend this kind of traditional Chinese meaning together with the bamboo structure or construction. It also blends in bamboo. That's the entrance. We can see it's kind of middle sized. I would use the term. The height of which is about 20 meters, and the opening about almost another 18 to 20 meters. So you can say from this picture, you can say the structure system with single bamboo. Instead of a bundle of bamboo, we just tried to test and to do the extreme with with less bamboo than the bundle of bamboo. A bundle of bamboo maybe will be using 4 at least and 8 or 12, depends on the span and opening of the structure. So we just use single thing. And that's together with lighting, you can see, okay, the atmosphere here darker. And for sure, structure thing is something crucial for this project. We do a lot more tests on that, and we do with computer, with help of computer, with software to do the calculation and simulation, and to try to find the optimized way to combine both structural principles and aesthetic meanings of architecture, which is also essential for architecture. So we just try to find the joint connection and do a lot more options and do a lot more potential schemes for structure thing combined together with architectural concerns. And definitely for each and every structure have benefits or you know have weakness. So we try to trade it off to find a balancing point and to meet all the demands from both structural side and to architectural side. with help of engineers, we do the calculation and find the displacement and with the load barrier, wind load test, and also for snow and for this kind of thing. And we finally find the way for the main structure for the substructure thing, different system. And still, there's some experience we obtained from an earlier project. That's one project in Beijing. It's for a pavilion for a garden festival for a university. So we tried a kind of 3 layers structure system. One is a bamboo, single bamboo. You can see that. The second is about the grade of split bamboo, and third for the bamboo tile or the kind of PMMA membrane for water, both not only for structure but also for waterproof. Yeah, that's the composition of the whole thing, the the main structure and substructure thing, and then the grade and also the layers, tiles and waterproof material membrane, and that's the detailing for that. And that's a section. You can see, okay, the height is almost 20 meters. And you can see the opening almost the same as the height, and you can imagine the space. It's kind of huge. I would use the term mid-sized just in the Chinese context, because in China, huge projects everywhere, so it's kind of small thing. But talking about the challenge of single bamboo, it's kind of huge thing. You can see for exhibition, during the exhibition, expo thing, a lot more events could be held inside of the pavilion, and also afterwards could be used for exhibition, even for wedding ceremony, a lot more things. And talking about the bamboo projects and with the open, without kind of the totally enveloped, I'm just as I showed before for the ancient Chinese painting, we tried every project for multifunctional, to be multifunctional. Could be for expo events, could be for I mean wedding ceremony, could be, you know, kind of just a leisure space, could be a tea house even, which makes this pavilion more flexible for to be used. And together we against the talking about the thermal comfort, we made full use of the electric fan, you know, instead of fully depends on air conditioner. That's the pavilion under construction. The workers, they were really skilled and dedicated to the whole thing. They a lot more challenges just behind, because architects drew something and discussed with them and also with clients, the INBAR organization, and then made the final decision. And together with the workers, without the workers, this could never be turned into reality. But during the course of that, we learned from both sides, from each other. The workers learned something from the, I mean, architects, and we architects learned also something from their side, vice versa. So we work together for detailing and for construction and for the material thing. So that's a great memory for both of us. That's the entrance. Also with the bamboo tile is kind of, you know, regular elements for bamboo building, or I would use building or instead of architecture for bamboo thing, because also not only because from bamboo, but also because it's kind of essential for an architecture for a building to be, to prevent the building from damage from rainwater thing. So that's quite important, and we just use the bamboo tile for that instead of other materials. That's a pavilion. Or you can say Professor Lu. Yeah, here. Yeah, our leader, and also you can see the case and during the expo events, and afterwards could be a tranquil space for a lot more potential events or activities. And the night is also another kind of atmosphere. But bamboo things always charming for architects, not only but also for clients and also for users, because it's kind of intimacy with nature, not only even the smiles, the fragrance, and the color of that. You can touch it. That's totally different from concrete or steel thing, the cold, and so it's warm, it's nice. It makes people feel nice with this bamboo thing. That's also yeah, it's hard to imagine the real size of the space. I always say it's almost a 20 by 20. It's kind of huge thing. If you imagine a human being with a height of 1.8, it's only, it's almost quite small in comparison with the space. And I would also like to present another example with bamboo that also goes together with a little bit earlier with the INBAR pavilion, and also quite important for a bamboo series from iOffice. It's a team market. That's also kind of challenge with the big span and the height, and for also to cover a relatively large space. So because it's a great opportunity to share something with distinguished guests and experts. I would like to to hear from you about the feedback of both projects. We're trying to look for the materials in the limits of 20 kilometers. That's in Fujian with quite famous in Chinese context with rammed earth dwelling for hundreds of years. And also another very particular way of making bridge with timber called woven timber bridge. You can see that. That's just nearby. Only several kilometers from the construction site. And also we find a lot more vernacular thing, like rammed earth, like even the stones beneath the rammed earth wall as foundation. And also, it's relatively old, and the young generations are not so fond of living inside of this kind of thing, so abandoned and as kind of solid waste to be treated or to just to throw away. So we try to reuse them, and also together with the stones timbers, very good quality timbers with even after decades still very good quality. We try to use it in the new project. And also Fujian is famous for the production of stone. Most of the stone on the envelope of the buildings of Beijing, Shanghai, Guangzhou, and Shenzhen, at least a big portion of the stones are from Fujian University, different type of granite, and which also leads to this kind of garbage, the trash thing. The broken stone plates cannot be used in the construction site in the big cities, but just discarded here. So we try to make it reusable So earth and also live material treatment, craftsmanship under 20 kilometers. That's the bridge nearby the site. So as I mentioned, almost the same way to make joints of bamboo thing with rope, with bolt, and some reinforced with a steel bar or rope, just this kind of thing, and together with the ramped earth by local people. Yes, we also do the same research on the structure thing and also reuse of the, the stone, abandoned stone with the local craftsmanship and also local people working for the ramped earth wall. 2 people, 2 days per piece of wall. And also we do kind of modification. We inserted some timber. We call it a timber break. Actually, it's not break. It's kind of just a timber inside of the rammed earth wall, just in case in the future we just for multifunctional thing. So if they want to hang something on the wall, they can nail and then use the timber. Local people with local tools for themselves. Actually, that's buildings for the villagers, and that's the woven timber or watered timber bridge just nearby, and you can see an old bridge with traditional craftsmanship, and also that's also another traditional Chinese, one of the most famous painting in Song Dynasty, Ming Dynasty, called that's just a daily life at that time in the capital city. And also we call it the Rainbow Bridge. And very interesting, Leonardo da Vinci did same research on that. So we do a lot more comparison on that for aesthetic. Yeah, because we are architects, we always working for something new, something different. If something beautiful, that's blessed, So we will do the separation, calculation, and do the research on the joints exactly the same way we did for the INBAR pavilion. And we do the joints research and also for construction and for experiment and for with people, with workers, with engineers, and after a very short period of time, it's done, it's finished. So that's for research, that's under construction, that's after construction. And for local people, yeah. When we are doing the bamboo projects, because bamboo projects, we need a lot more national codes and regulations to support to as ordinary building, just like Professor Knudsen mentioned for dwelling. For sure, if we are adopting bamboo for dwelling, we need permission, we need guarantee from national codes and regulations, which we are still working hard for that. But it's open space. It's open. If it's open, it's not totally enveloped. It's something different. It's not ordinary building with kind of function for dwelling, for theater, or for whatever, for school building, whatever. It's just a kind of, it regards as temporary building. So could be this kind of open, it's not totally enveloped. I will describe this situation this way. You can say, oh, could be a tea market for local people, could be also some events, a lot more events, multifunctional, just as the INBAR pavilion could be movie night for the villagers. INBAR pavilion and this tea market, for sure, the clients are different. INBAR pavilion, the client is INBAR is kind of international organization. So as for event, it could be something for the people living in the city. But the market for rural area, for people in the rural area, could be grocery, could be tea house, and also could be the space for the local thing. It's kind of local faced. Yeah, in a particular time, um, every family will make dishes and just share with the neighbors, with the villagers, even with the tourists. Usually, this event is taking place on street. After the accomplishment of the tea market, it could be sheltered from rain or from sunshine. Yeah, that's kind of thing. That's under construction, almost done, and that's a detailing for the roof, the bamboo structure, and under construction. The villagers are quite curious about the material bamboo because the bamboo we have a professional manufacturer of bamboo and bamboo contractors they are quite professional. The bamboo are pre-treated, treated for long longevity and for against a lot more weather thing. The timber reused for benches around in landscaping, and also
Sorry
the rest
to
material
interrupt.
bamboo. We just make full use of that for furniture inside of the pavilion. And if you look at the floor, it's a terrazzo with a abandoned broken stone plate. We just knock it more smaller and with terrazzo thing. Maybe it's not so clear, but it's kind of terrazzo. One of my favorite material for floor.
Professor Song, I want to
Yeah,
remind you 2 minutes left.
yeah, 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 only. Yes. Okay. Yeah, that's a structure thing. And that's reused timber. Local people are in there. And also the detailing for. Oh, that's another way of using the abandoned stone plate for pavement around the building. That's nice view. Okay, that's all. Thank you. Thank you, Kewei.
Thank you so much to share with us your understanding of how to use bamboo. What bamboo is, what kind of the material bamboo is from its micro structure to the round pole to the real kit projects. So Professor Song highlighted two very interesting projects with us. So also great thanks to his contribution and his team to help INBAR design such cute and little fish. So it's sometimes we call it's a little fish, but if you have chance to travel there, when you stand inside of the pavilion and look up to the top internal structure, it's really big and it's a marvelous design. So it's like a cathedral. Because of Professor Song's excellent design, our INBAR Garden this year also received 2 big awards. One is International Association of Horticulture Producers, and another one is Grand Awards of International Outdoor Garden. So thank you so much to Professor Song. Let's move to the third speaker, Professor Neil Thomas from the UK. Neil is also the member of INBAR Bamboo Construction Task Force. His topic is bamboo engineering. Neil is the founder and the director of Atelier 1, a Royal designer for industry, an honorary fellowship of Royal Institute of British Architects, the fellow of the Institute of Structural Engineers. In 2016, Neil was honored with a member of the Most Excellent Order of the British Empire on the Queen's 90th birthday for contributions to architecture, design, and engineering. Since visiting Bali over 7 years ago, Neil has become more involved with the design and development of bamboo structures. He is a regular lecturer at Bamboo, an adjunct of Green School Bali, teaching the engineering principles behind bamboo design. He also holds a number of high-profile posts in the UK and US educational service, most recently being a visiting professor to Yale and MIT. Welcome, Neil.
Thank you very much. Can you hear me?
Yes.
Can you see my screen?
Yes, please go.
Anyway, thank you very much for organizing this, and to all the speakers and guests. It's an honor to be invited to join you and all the participants. It's great to see such a large number of people having such an interest in the material. But for me, I only discovered 9 years ago, but it has changed my life fundamentally. But I thought what I would do is talk about how I arrived to be working with bamboo. We've always, as a practice, I run an engineering practice with my partner, Aaron Chadwick, and we've always been interested in the idea of materials and how you use materials in the way which understands them and uses the properties of those materials as best you can. And this is a building that we developed for central London with the architect Richard Rogers and partners and Cambridge University. And it is using a timber, a densified timber called baobuk, which takes the kind of normal properties of timber and compacts it so that you get increased strength. But when I said you have to understand the kind of properties of materials, timber, a natural material, has a kind of quite a low elasticity, or it can flex quite a lot. So the way this was developed, you can see it here, we've taken the structure of the whole of the building and pushed it all the way to the outsides, because any of you who are not engineers on the call, if you understand the kind of elasticity, the motion of the building, the movement of the building, because timber is a kind of relatively elastic material, it can move a lot. The further you put the structure out, the stronger its ability to be able to carry load is. So we're always interested in the idea of these materials and properties. We developed the engineering of a building called Woodland Trust, which is for the people who are actually look after all the forestation in the UK and beyond. And this building we developed with the architects Phil Clegg. But this building is really interesting. It uses cross-laminated timber. So again, kind of thinking about different types of materials and how you put them together. But what you are looking at here is a view along the length of the building. And where that guy is in the center there, you can see a series of steel columns. And those columns support a beam running down the center of the floor plate, the roof plate is actually you're looking at. And what we did was develop a structure for the roof plate, which is made of cross-laminated timber running from left to right in the image. But you can see those white planks suspended beneath the roof plate. Well, what those white planks are very thin concrete radiators. And we added them to the cross-laminated timber because what it does is dramatically improve the stiffness of the span, but it also provides thermal mass. So at nighttime, the ventilation systems, you can see the windows at high level on the left-hand side here. During the summer, they let the air pass through those windows, over the ceiling, and that puts cool, the panels take up cool during the night, And so when they return in the day and it becomes very warm, those panels re-radiate the cool, so effectively creating free air conditioning. But what we did here was take the timber, combining it, making it composite with the concrete in a way that had never been done before. We won an innovation award for doing that. So what I'm saying is we've been interested in natural materials for a long time. This is the very recent, only just opened, the expo in Dubai, which is a building we developed with a stage designer called Ez Devlin. This is also built from CLT, but actually took an enormous amount of work because of the three-dimensional nature of it. That building is now open, and if you get the opportunity to go to Dubai and see it, it is really quite a remarkable building, but it's a shell formed from CLT planks that you're seeing there. So those three things I've shown you, I've been over it. There's all sorts of other things, but this is using timber in a kind of engineered way, which is one area of work that we've been looking at in bamboo as well, but also in timber. We've been looking at using timber in its natural form. And imagine, take a look at this picture here. Imagine that rather than take timber and cut it into sections like this, and actually when you normalize a section of timber from its natural form, there's a lot of wastage. So imagine instead of doing that, you took the timber and took it in its form the way it came from the tree. Like that section at the bottom, you see there where it says Fig 706, at the bottom, that Y shape. We worked with the AA, the Architectural Association, in London, in the south of England, in a place they own, and they have 100 acres of forest. And they were due to build a, sorry, just one second. I can't go down. Okay, but I'm really sorry. It's just me at home. Anyway, imagine that you took the timber in its natural form like that. So the 100 acres of forest down at Hook Park. And what they did was they developed the design for a kind of storage facility, and they developed a truss design where we took the idea of very loose fit design on the truss. So we took the idea of the truss form itself, and then we took the scanned trees from around the site and put them together like a puzzle. And then, using 21st century technology, we took those elements. You can see that Y shape there on the piece of timber that stood on the robotic arm, and then machined the ends of it because of the accuracy of it to create joints between those timber elements. And it meant that so we could create a female and a male connection like the one you're looking at here. And because the way we designed the truss and the way the roof is designed supporting the truss never goes into reversal. So you don't need any connection, physical, mechanical connection between the male and the female. It just sits in and it stays in place. So you can see here, if you can see my cursor, the kind of Y-shaped elements. I mean, we still had to add certain other pieces in to kind of create the overall truss, but in principle, it's based upon taking. So we're using 85% of the material of the tree in each of these elements, which is pretty amazing. So you start to think about not using just the material in its engineered form, but in its natural form. I mentioned that I discovered bamboo as a structural material 9 years ago. If you look at the website of Atelier 1, I have a kind of another career. I've worked on stage set design for the last 25 years. We've designed and engineered stages for Pink Floyd, the Rolling Stones, U2, more recently Beyonce and Jay-Z, and we're currently working with Coldplay on their new tour. And the architect who I worked with over those 25 years on those stages, a man called Mark Fisher. Unfortunately, about 10 years ago, he became very ill and died. But just before he died, he said to me, I want you to do something. I want you to go to Bali and find John Hardy, this man. And I had no reason to be in Bali apart from to go and see John. I did not know what was going to happen when I got to Bali, but as I said to you, it changed my life completely. John, if you know of him, he had a jewelry brand which he developed when he was in Bali years and years ago, and he had children with his wife, and they were looking for a school to put their kids in, and he said they didn't really like any of the schools, so they decided to start their own school, which is pretty impressive itself. This is it, you're looking at it, the Green School in Bali. It is entirely built from bamboo. It is built without walls and doors. And interestingly, the kind of physical not having walls and doors, it's also it's a psychological thing too, that actually the openness of it is immediately apparent. And when I got there, I could not believe it. It was unbelievable. Absolutely. I spent, I don't know, 3 or 4 days with John in Bali, and he took me around and I saw things that were just, they kind of shook me. And I went into, and I talked to people about the fact that I had seen these things in bamboo. People thought it was a joke, that we were going to start talking about engineering things in bamboo. People, if you don't know bamboo as a material, there's a kind of real, there's a kind of odd misunderstanding of its possibilities and the capabilities. And I have now, like I said, since those 9 years, I probably spend at least 50% of my time working on projects with bamboo now. And what is it about bamboo that's amazing? It's light, it's incredibly strong, and it grows at quite prodigious, phenomenal rate. I mean, that diagram there on the left, that 8 a.m. one day to 8 a.m. next day, 5 centimeters or 2 inches, it's grown. You can almost watch it grow. John had a factory built for him, for his jewelry, by a man called Yongjiu, who is a German living in Colombia, who I've now met, who's become a very close friend of mine. But he built this building. He was a huge fan of Friotto, or is a huge fan of Friotto. So he's combining structures like the compression elements you see in this reciprocal form with bamboo acting in tension as a hanging system, like cables that you would in a kind of in a tension structure, like the work of Friotto. So he was combining bamboo in a way that was quite absolutely groundbreaking. John's daughter, Elora Hardy, she grew up with bamboo as a child. She was one of those children that I was talking about. She went on to do design and work with Donna Karan in New York, and then went back and began designing larger projects. And this is one of the houses she introduced me to, Sharma Springs. It's a house built entirely of bamboo, 6 stories, so 3 half stories on either side for a private client. And what's amazing about it is the way she designs. She says she has to get into the kind of feeling of bamboo, the way bamboo is. It's a natural material. So although the structures that you're looking at are relatively straightforward, this is kind of known as post and beam. But it's the way they combine them together, the number of culms of the bamboo, which gives a level of redundancy, which is something you really need to think about when you're developing structures from natural materials. But it's astoundingly beautiful. Again, the work that I've been developing through Atelier 1 over 25 years, we've been really interested in the idea of structure and form. And I think this, I told you, relatively straightforward post and beam idea, but we said to them, when we eventually, after a couple of years of studying and getting to know and understand the nature of bamboo and how it works, what the great properties are about it, if it has any kind of things that you need to really think about in terms of the way it's engineered. And we said, well, look, why don't we take small diameter bamboos and start putting them together in a way where we're using shape to give them stiffness. We call it geometric stiffness. It's shells, and it's taken from nature in a way, again, listening to Elora and saying, you know, think about how the bamboo wants to be. What we've begun to do is to start to look at shell shapes and surface stiffness so that you can use small diameter sections to create larger spans. This is a moon house that John Hardy has a hotel there called In a Bud, and this is one of the houses that you can go and stay at. Kewei mentioned that I actually gave up teaching in MIT and Yale because I was teaching in North America and teaching in Bali at the time. John Hardy's son started a thing called Bamboo U, which is a course which we did. The first one was with the Architectural Association in London. And there they have a kind of immersive experience of 10-day kind of workshop. And I used to travel there for 3 or 4 days and work with the students, lecturing about bamboo, lecturing about a variety of other things. But more interestingly, they built stuff as well. And this is in fact a model of a workshop. And something they always do, by the way, is build models when they're looking at the design of structures, because they kind of get to understand them physically. This is a model of a workshop that they went on to build with the students and some of the craftsmen that work locally. This is a design that we did with Yongjiu. I mentioned the Colombian who also travels backwards and forwards to Bali and does these workshops. But here we were able to take straight sections of bamboo column and combine them in a hyperboloid, so that actually by forming a surface from straight lines, so you get a doubly curved surface, which again is beginning to think about the idea of shape stiffness, geometric stiffness. We also used the bamboo, the kind of flattened bamboo as the tiling system for the outside of this workshop building. But we didn't here do it. But what we've kind of noticed is that when they put the tiling together on the surface of the bamboo, you get a connection between the surface and the bamboo columns themselves. So actually what you can get is a composite stiffness between the bamboo members and the surface. So you get shear resistance. So you're able to take that high power and make it work properly as a complete single surface, like leaves. If you look around at leaves, particularly doubly curved leaves, that's how they work, with the ribbing on the back. We took it a stage further. This is a big leap further, actually, because this is actually working with Elora and her company, Buku in Bali, but also with a Mexican architectural practice called Arquitectura Mixta. And we worked together on a proposal for a new green school in Tulum in Mexico. And so I've traveled backwards and forwards there many times talking to them about the development of design. But you can see conventional grid shells appear to be, they're kind of using orthogonal grids, meshes in these ways. But what Elora wanted was, again, to kind of take that to a different level. So this is kind of looking at the outer section of part of this, what is the heart of school building in the new green school in Tulum, which is the kind of administration office. But they give them these really beautiful names, which actually, again, fits perfectly because the nature of them and where they are and what they are. But we developed a grid shell where we were now beginning to investigate the little moon house I showed you where we bent the bamboo. What we're doing is using a technique called elastic bending. So you take a thin bamboo pole and bend it into shape, and you induce a pre-stress. So it's actually it combines that kind of pre-stress with the form of the surface to create a stiff shell. Where the roof needed, we added further layers into it because, I mean, this is a big roof we're working with. And the Mexicans, Arquitectura Mixta, they began to experiment with the active bending or elastic bending testing. So they set up this system where we could bend and find out what level of pre-stress you could induce. And then we pushed it through and broke it. So we're able to see precisely what amount of curvature we could achieve and still have capacity to carry the loads from the extreme loading conditions that they have in Mexico. We did a whole load of 3D modeling and analysis with a guy called Greg Quinn, who is someone we've worked with for quite a long time. He's developed software specifically for this. He developed a system of inflating grid shells into place, which is very interesting if you want to have a look at the thing afterwards, Greg Quinn. And here you can see this is the mesh of the shell itself. And this, as it becomes more dense around the base, as the loads build up. So we continue to add layers, much in the way Friotto did in his very famous grid shell in Mannheim in Germany. If you get a chance to take a look at that, please. But the key to how the grid shell goes together is these connections. And in fact, the key to how bamboo works and in natural materials is the connections between them, because I mentioned that you need to know and understand the properties of bamboo. Bamboo is amazing in tension and compression because the way it grows, the vascular bundles are longitudinal up the length of the stem, but it has very little connection in its circumferential direction, which means it has quite low shear capacity. So when you think about how you're connecting bamboo together, you need to think about how to put together a material which has incredible, longitudinal capacity, but low shear. And interestingly, the way everybody's doing bamboo historically in that way is, I showed you, saw the bindings and things there, but using dowels, these are bamboo dowels. What you're doing is relying upon the shear of capacity of the bamboo alone to transfer the force. And we thought, well, hang on a second, what about if you think a little harder about how to join it together? And we took inspiration from the bamboo bike, this bamboo bike, which is pretty impressive in that, if you think about the forces in a bike, they're pretty big. 100 kilograms on a small, and then bouncing along on the road and all the dynamics of it. But what it does that's really clever is it wraps the bamboo around the sleeves, which means you're transferring the shear from from the bamboo into the kind of rest of the frame and through the wheels via a mechanism which allows you to improve the shear capacity. And so we thought, well, let's have a think about that and what we can do with it. So we developed this nodal connector on the left. And what's different about it is to the bamboo bike I showed you, is we also have this internal series of prongs which actually allow the thing to fit tight within the bamboo. And then you ask yourself, well, okay, that's great, but bamboo is a natural material and varies. It's the image on the right, larger diameter on the bottom, smaller diameter at the top. It varies all the time. So we continued to develop the idea of that connector having a series of stepped versions. So that means we can take two bamboos of roughly the same diameter and be able to attach them together by the use of this stepped mechanism. And finally, the thing we developed, you can see on the right here, which is the nodal connector. And it's like a micrometer. If you know, if you're a micrometer, it has a large crude scale and a very refined scale. So you use the overall crude scale to fit the two bamboo pieces together. And then it has these canals. I have 3 daughters, and they all play hockey. And this is how their mouth guard works. They have a very crude outer layer. And then you put this putty in and it takes up the kind of fine detail. So what we would do is inject adhesive into the bamboo. So it creates a bond between these two pieces of bamboo. So if it starts to buckle, or if you bend it, it cannot buckle due to shear or break due to shear because it's contained within the connector itself.
I know. I want to buy you 5 minutes.
Okay. So bamboo, I haven't even got to the arc. So the bamboo connects. So now this bamboo thinks it's continuous because transient shear and tension. So you could begin to look at bamboo nodal connectors, which will allow you to do something like the roof on the right, which is a thing we engineered in Melbourne. It's actually steel, but the same thing applies. This is using shape stiffness again. This is the grid shell Friotto did in Mannheim which is a really, really beautiful building and uses these layers of 5 centimeter large. But it allowed us to start thinking about, John asked if he wanted to develop a great hall, a building for the Green School. And we started to look at using shape stiffness, combining it with environmental principles. So these towers are actually black bodies. And because black bodies heat up more than the white bodies do, it drags the air up through like a chimney, a stack effect it's called. And I'm showing you a lot of natural materials. Bamboo can also be considered in an engineered form, the same way as I showed you the timber. This is radially laminated bamboo from a company in the USA. The properties are unbelievable. I mean, I can't go through them now with you, but you can take a look at them later, perhaps. We were asked by a developer in the UK if we could come up with an alternative system for a concrete floor, you know. And we proposed, again referring to nature, the idea of a folded plate. So that's the idea, using the depth of the floor. So there's the concrete version on the left, there's the kind of natural material version on the right, either bamboo or timber. And we managed to achieve, because I mentioned earlier on about the elasticity of timber, because we can achieve the depth, then that means we are able to deal with the vibration issues, which are major issues. And we started using joinery techniques from Japanese joinery. The project that was mentioned earlier on, which is an amazing project has been for us, is the Green School Gym. This is the last thing I'm showing, and it'll be just 2 or 3 minutes. We developed a structure, again with Yongjiu and Elora, and here we were combining parabolic arches, crossed over so they linked together with a series of surfaces made from split shells. We did a huge amount of analysis work, remembering we are trying to create what is effectively like a rib cage, like nature again. We're combining the 2 things together so they work together. We did an enormous amount of testing. We used a technique of cutting the bamboo to allow it to be curved and then reinforced it again. This is it underway in testing. And I mean, this is what the incredible thing about working there is if we need, there is no documented information about these things being combined. Here, this is a composite section of 6 columns. We even they built a full section of the shell. So what you're looking at here is the split shell using an orthogonal mesh, where we've applied the flat bamboo tiles to the surface and connected them in 2 directions so that we form it as a full shell, a stiff shell. And that combination enabled the surface to work and carry the quite huge loads from both the earthquake, really, but the wind and earthquake, which is the key condition, earthquake. And then, quite amazingly, the incredible quality of craftsmanship. They went on to build the shell and added this surface of the tiling you see on the roof here, and it created the most, I mean, the effect on the inside is quite stunning, unbelievable. But it was this thing of combining all the thoughts together we're having of shape stiffness, the nature of bamboo, Elora, and her kind of understanding of it. And my favorite picture, it's a gym for the Green School. It's actually just won an award for Architecture Master Prize. It won the award for the best building of 2021. So I'm very proud to be able to share that. And thank you very much. I hope I didn't go over time there. Anyway.
Thanks a lot, Neil Thomas. Neil shared with us his experience on not only on bamboo construction, but also on timber structures like COT structures, and also shared with us some kind of the ideas how to deal with joints of round pole bamboo structures. I think there must be lots of the questions raised in the chat box. So I will hand over to Professor Ken Harris to moderate the panel discussion. So Kent, the floor is yours.
Okay, thank you, Kewei.
Shall I stop sharing? Oh, you probably don't.
Yeah, actually, Neil, if you wouldn't mind. Thank you.
Sorry.
And so given that we have a more than 200 people online, I'm going to sort of be the one asking the questions. Excuse me, I'm certainly not going to be the one answering them. And so I want to invite each of the speakers back, Professor Knudsen, Yehao, and Neil I can see Neil there. And initially, I'm just going to kind of start rotating through, and we'll start back, I think, with Professor Knudsen. And I've got a couple of questions that are sort of related. Raul Hidalgo, Anthony Kilbride, just talking about, I guess, the star houses and why, or if you can clarify why the use of very energy intensive steel materials were used. And then kind of as a follow-up, when does bamboo come back into the picture? Is there a plan to do that then?
Yeah, thank you for the question, and thank you for the two other presentations. I think it's a really great body of interesting bamboo knowledge we have here this afternoon. When the reason why we use steel was that first of all, we couldn't make it in bamboo, for instance, because there is no bamboo in the area. So it was not an option. There was no material and there was no bamboo carpenters. So this is not an option. So that's one reason. The other reason is that we needed to build 110 identical houses because this is part of a medical experiment. So these houses have to be absolutely identical in order to demonstrate the effect of a new house. But for the properties of the house, we could use any material. We could build it in bricks, we could build it in steel, we could build it in bamboo or wood, because it's the geometry and it's the ventilation and it's the kind of the way we treat the overall form of the house, which is the most important. So that's the reason for the choice we did here. We hoped to make it in wood initially, but it proved to be difficult too. So we ended up with steel. I think we are very enthusiastic about using bamboo ahead of this, and that's why we're trying to look for bamboo opportunities. We're looking for how to also encourage people to grow more bamboo. We are starting a small factory now where we are trying to do good bamboo timber and to make furniture and other products. So we're trying to promote bamboo in general to kind of make it accessible for a wider audience.
Okay, and then I'm just going to actually follow up a little bit. There's a related question from Daniela Cadena, and I'm going to read this. While these prototypes that you're talking about help to improve the health of the inhabitants, the applications of materials such as bamboo and wood, let alone steel and concrete, have an impact on the architectural and cultural context.
Yeah.
And then how is that not invasive on the identity? And I'm assuming here in the architectural identity. I mean, obviously, like you were saying, a steel, a brick, a bamboo, and an earth construction is going to look very different, I think,
yeah,
and feel very different.
You can say any architecture, any new architecture is to some degree forceful and doing changes to the identity. What we are trying to do is to work very careful with local communities and to discuss these examples. And we try to go to the same areas, to go to the same villages, and to build prototypes, not over time, to kind of keep the conversation going. And our experience is that people also in Africa and the most rural areas are actually very keen on getting a discussion about new architecture, how to improve their life, how to get on, and change needs to happen, because some of the construction principles are not very sustainable. Some of them are, but also what you see today is that people are building actually with a lot of energy in the most poor areas. You feel that there's very little knowledge about how to use materials in the right way. And so you see, for instance, that concrete is used in ways that are kind of just using too much cement, too much material, too much steel, too much everything, because there's a kind of a lack of proper knowledge. So things need to have. And one of the big problems I find in Africa is that there's a lack of kind of a good education for not only for architects and engineers, but also for masons and carpenters, and kind of in general in the construction business. There's a huge need for better education to get better constructions.
Okay, thank you. We're going to jump around a little bit here. If I took a poll of the questions that came in, and we've got a number of related questions, and so I'm going to relate. These are mostly to Yehao and to Neil. But and anybody can jump in. But some of the participants want to know about the species that were used in the projects, which I think we can address to Song first. The treatments that were used, and also then sort of extending that, what is the anticipated durability associated with those treatments for the projects that you were talking about? So I'll go to Song first, if that's all right, and then we'll circle back to Neil.
Okay, thank you, Ken. Thank you for the questions. We are using one of the largest species, bamboo species in China called Moso bamboo. It's quite just very popular in China. And the treatment, yes, several processes are taken before from elements to components, boiled with particular thing, and but that's kind of patent thing, yeah, by the bamboo manufacturers, and they guaranteed kind of durability for some will guarantee for 30 years, and some for 15 or 20, just something like that. Okay, Ken?
Great.
Okay, thank you.
Neil, do you want to add to that at all, your experience maybe in Bali?
Yeah, I mean, in Bali, the bamboo they use mostly is can you hear me? Dendrocalamus asper. And they use, in fact, but John Hardy, his wife, his first wife, Linda, can't remember her surname now. She came up with the kind of technique when she saw them people taking bamboo down the river, because it leaches out the sugars and the starch from it, which is what the insects like. And so they use borax as a treatment now to do that. You can do it simply in water as well if you want, but it takes a longer period of time. The thing is, it's very important when you've done those treatments, which are the things that kind of resist infestation, you also have to protect bamboo from the sun. It doesn't like water. It doesn't like the rain. So there are, I mean, interesting looking at the projects that Professor Song showed. The thing is the way you kind of detail the overhang for canopies for sunlight and things is very important, because otherwise it may have a durability of that long, but you still need to take care of the way you detail it. Don't sit it in the water, it will rot straight away. So that's why if you ever look at the kind of foundation systems, or the systems in Bali they sit them often on a stone above the ground, like a little pedestal, so that the water, they don't ever sit in water. These things you only discover after kind of spending a lot of time there. In South America, they use guadua. And I mean, there are a number, I mean, as everybody I'm sure knows, there's thousands, 1,600 species of bamboo in the world, half a dozen that are kind of the real major ones that you would use. And guadua and Dendrocalamus asper that we work with, I have both two of those major ones.
Thanks. So Neil, you actually
was I not sounding right there, Kent? Did it not sound right? Is there something wrong with the sound?
You are getting a little bit warbly. I think there's a digital issue, but I think I can understand you. I don't know if everybody else is having the same problem.
Okay. Apologies.
So just kind of following up on that, because you touched on it, there was a question from Severin Tamwo, and I believe this was related to the Green School, and particularly I would say the taller structures, John's house and what have you. I've had the pleasure of meeting John and actually visiting there as well.
I'm sure you have.
Can you briefly, what do the foundations look like? Because now we're talking about much larger loads than potentially some of these one-story structures that we often tend to look at.
That's interesting, because I had a meeting about foundations this morning for a new building that we're doing in Bali. So, and we are investigating micropiling. And part of the argument for that is, and I think it was mentioned earlier on about these huge volumes of concrete. Yeah, I think Jakob, it was you, mentioned the misunderstanding, the kind of nature of it. So we've been trying to develop with John and various other groups as well, the idea of foundation systems that reduce the volumes of concrete involved. But it means, I mean, micropiling is a great solution, and we've used it a number of times in housing in the past. And it just means that, you can carry a lot more load with a lot less. But some of these buildings, like the Green School gym, they are big now, 20 meters across. And because of earthquake, the forces are very large.
And what about the transition then to the bamboo? I mean, micropiling is the foundation itself. I agree. Maybe I didn't ask.
Yeah,
the
there's still. I mean, we're still using a kind of small concrete pile cap because they're designed individually to suit the particular condition. But it means we're using, you know, an order of magnitude less concrete than we would be using if you were using mass foundations or some other kind of bearing foundation.
Okay. So I think I'm going to, as I said, I apologize for jumping around. I want to make sure I try to get as many of these questions in as I can in the relatively short time that we have. Excuse me, I'm sorry. Sorry, I lost what I was going to talk about. I was actually coming back to Zhang, and this is a little bit related to foundations, a little bit related. Neil brought up the seismic issue. You talked a little bit about the integration of bamboo and glass elements, and I'm wondering if you can comment, window elements. I'm wondering if you can comment on the challenges associated with that, in as far as a bamboo structure is generally relatively flexible, and glass panels don't particularly like flexibility.
Who were you asking that question of, Kent?
I'm sorry, that was primarily for Zhang, I think, because
yeah,
that was the discussion early on in his presentation.
Sorry, I beg your pardon because the signal is not so good. Hello, Kent, could you please?
Yes.
Yeah, I beg your pardon.
And let me try that again. So you talked a little bit about the integration of bamboo and glass elements and window elements. And if you could comment a little bit on the challenges involved in that, given that you've got a relatively flexible structure in the bamboo, and obviously glass is not particularly happy being mated immediately with flexible structures, as it's a relatively brittle material.
Actually, we talking about the project we have accomplished, nothing to do with glassing. We are using kind of a PMMA membrane thing. Yeah, it's kind of very much flexible. It's lightweighted and transparent and very well waterproofed and this kind of stuff. And also talking about the structure thing, maybe we are trying to do the challenge for the single bamboo system. It's not bonded, as Neil shown in very nice projects. We are wondering about the durability for the whole thing instead of the structure thing. For instance, personally, I strongly believe that the durability for a bamboo building or bamboo structure, yes, maybe relies mainly on the longevity of bamboo instead of the structure. So I never expect that bamboo thing could last longer than a concrete or steel building. And even I do not dare to touch that field to think about making bamboo thing ordinary building, because we are quite lack of professional codes and regulations. Without that permission, we are legitimately saying we are doing something illegal. So we just do the flexible temporary structure thing. Okay, Ken?
Okay, thanks. And I'm actually going to circle back to that a little bit later. But sort of on a related question to Neil, and this was from Dolce Panzalan. You've got very large grid shells in the arcs structure. Can you comment on the buckling resistance over these? And I guess she identified 14-meter arches. Is there a buckling issue, and how is that addressed?
Yeah, there is a buckling issue, and it's a very good question because it's something we spent a lot of time looking at. But the thing is, because of the anticlastic form, the surface shape, which is the opposed curvatures, which is a negative curvature to curvature and a positive curvature, you effectively reduce down the effective length of the shell elements. So the buckling becomes a kind of property of the overall form rather than the kind of, there's a local condition too. But because you've got the property of the overall form, and again, I would recommend people look for it in nature because it's there and you can see it right in front of you. What happens is, because the shape of the thing becomes very stiff, that actually it provides some overall resistance combined with the bamboo arches themselves. They are parabolic in form, which is parabolic's great because again, it's what nature does. It's a hanging chain turned upside down. But what it isn't great in is wind load and earthquake load because they're horizontal forces. So it's so the parabolics are there for the self-weight of the roof, but then the combination of the shell and the arches combined together get a kind of composite stiffness. It's a not enormous effect, but it's there and one that we took advantage of. I hope that answers the question. I believe we're going to publish a paper on the analysis of it in the relatively near future. So, Dulce, is it? Dulce Punzalan?
Yes.
Dulce Punzalan, if you look out for that, I think it should come out. It should be coming. Look out for it. We'll let you know when it comes out.
Excellent. That'd be great to see. Actually, just kind of following up, because you are talking about composite, and you showed near the end of your presentation. I'm going to get really technical on you here. I apologize. This is what happens when you talk to an academic. But you showed the beams under load and talked about composite behavior, but it was fairly clear looking at them that there was certainly some differential displacement between the columns. Can you comment on the sort of the degree of composite action that you were able to achieve? Because I suspect those beams weren't fully composite.
They are not fully composite, nor anywhere near. It's probably 30%. And actually, Ken, is one of the most critical things of the whole project was the level of composite action. I have talked to so many people about what you can achieve. And we use the bolting system connecting the thing together. But the problem is you get slippage in the bolts and movement between them. So you cannot achieve full composite action. That is why connections are so critical. And the more people are researching connections and things with bamboo columns, and the more and better understanding of how to connect them together, I mean, we will only improve. I mean, the codes, the recent codes, they kind of avoid there's not a huge amount. I talked to David Trujillo about it from Coventry University, who was part of the committee that wrote the code, and they kind of left out a whole section of it on connections because they just haven't got they wanted to get the main code out. I think it was Ken, the ISO standard you just sent out to everybody. And then there's a whole section on connections that they are kind of investigating. But it's such a huge subject because of its natural, the properties of it and it being anisotropic and kind of understanding the kind of nature. It's even along its length, its properties vary between the node and the internode. So it's a kind of really complex thing. But I mean, like I said, changed my life 9 years ago, and I'm very excited.
No, and I think I would emphasize what you said. So the current documents intentionally do not permit composite behavior to be developed. We permit summation of columns. And of course, in reality, you can get a certain degree of composite behavior. Something like 30% is better than the sum of the columns, but it's certainly not composite behavior. So that's encouraging.
Absolutely.
I'm kind of cognizant of the time here, and I really want to come back to one particular point that again relates to codes and standards, and this is primarily a question for Jakob. And I want to word this correctly because I think that you raised some really interesting interactions with the structural and the architectural world that we often don't think about. So how do you think we might engage building codes and standards or whatever these guides are that we use and engage that community, which is people like me who write these things, to begin addressing some of the issues that you're raising? I mean, I'm not really aware of code documents today that address public health directly. We talk about ventilate some things, but it's more on the mechanical side. And my question comes, living in North America, I'm familiar with the suite of I codes, the international codes, which don't directly address public health. Would you be willing to comment on that?
Yeah,
maybe not.
I think it's difficult. You see this discussion all over the world at the moment, for instance, about ventilation after COVID. Do you dare to say anything specific about ventilation and health? I've been following a bit the WHO. They're trying to make recommendations between public health and buildings, and it's interesting that it's the medical doctors driving this process, and they are looking for hardcore evidence. they are saying we cannot ask for things to be included in the code without having a solid proof, which is difficult because a lot of these experiments have never been made in the, there's not a great body of work that kind of conclusively would tell you what to include in a code. So it is difficult, and you can say the more you move towards countries that are not so familiar with a building code from the start, it becomes almost impossible. I mean, you have so many other subjects you want to take care of first that kind of getting health into the building code is also, it's going to be very difficult. But then again, you could say on the other hand, from 100 years back, we have had quite strict measures on water and sanitation and stuff. And there's no doubt that it is one of the greatest improvement of human health that we are kind of emphasizing this. So I think we are at the next level where we can try to look for other things. At the moment, WHO is starting now, very reluctant to recommend screening as part of housing to prevent malaria. But even that is, even though we would think most of intuitively that that's a good thing, they are very reluctant to do this because there's a lack of solid science still.
Thanks. Absolutely. I mean, we've sort of been engaging public health in codes. The Romans even had laws that related to public health, whether they got it right or not.
Yeah.
Looking at the time, what I'd like to do is I kind of have an overriding question that came in, and I'd like to ask each of the panelists to give a brief response. And this question happened to be, we were talking about particular projects, and particularly these very large signature projects that were being discussed today. And so in general, excuse me, how long is the process of and the logistical challenges associated with actually getting these projects built? Is there a real, for instance, is there a difference between using bamboo in these signature projects and more traditional materials? And how were some of these logistics overcome? I know, as an example, if I tried to build something in bamboo in a North American context, I'm going to have code officials say no, because there's nothing we can hang our hat on. But I'd like to go around the table, I think, and just ask each of the panelists for their, a brief discussion of their view or their experience in terms of getting these projects built. And I'll just go in order, if I may. So, Jakob.
Yeah. It takes a long time. For us, it was not a problem to use bamboo, but there's a lot of other problems. So it has been difficult. I was thinking as we talked about this, that there's also, is this restricted to only being a very local use to the tropical climates, or is it possible to actually export or use some of these, or can we transfer this knowledge of biomimicry into other subjects? For instance, if you look at the Sigrid Barn Pompidou Center, you can see that it's in many ways doing the same as Neil Thomas is doing, but I think in a far less sophisticated way, because you're removing so much material in order to make construction that looks like a bamboo construction, you can say almost, or weave construction, but actually it's a heavy timber kind of a mile into shape. So for me, it would be important if we could somehow link some of this knowledge, maybe not directly the bamboo, but at least it would be interesting. And I'm a bit sad that Zhang is not prepared to build other houses than kind of temporary buildings, because I think there is a possibility if we kind of challenge this. Thanks.
Zhang?
Yes.
You're muted.
Yes. I back. Talking about the logistics thing, I think take the INBAR pavilion as an instance. Just before we choose the right manufacturer to do the job, when the INBAR will make one of the determination making is on the location of the manufacturer. And also, actually, we got that just several hundreds of miles away from the construction site. Yeah. So, and talking about another project also, not far away from the construction site. So logistics thing for us is not a problem. And also bamboo thing, bamboo is quite, light, and for a truck can take a lot more things. Yeah. Yeah.
Thank you.
Yeah.
Neil, do you want to add anything to that?
Yeah, thank you. I mentioned when I found bamboo 9 years ago, I've been an engineer for 25 years, right? And I discovered a new material. Did I ever imagine I'd do that in the world? I mean, come on, man. It's just unbelievable. I've worked with structures of all sorts. Bamboo has these remarkable properties. Somebody asked, do you select bamboo for its age? You select it. This is a kind of issue, right? How long it matures, grows in 12 months, matures in 3 to 4 years. You have to be careful. You have to harvest it in the moon. There are things about bamboo like no other material. And so the codes, at the front of every code of practice, there's a line that says, if you can prove by other means. And that's in every code of practice. And so that's why all that testing that we did, we were trying to do things with bamboo that people, we're not perversely trying to do it people hadn't done before. We were just trying to create something. That's what Laura wanted to create. And along the way, we found ourselves doing things that didn't fit the codes of practice. We were the engineers for Gardens by the Bay in Singapore, if I can just say something. When we were doing that project, they asked us to design for 50 kilograms per square meter of load on the conservatories, 12,000 square meter glass conservatories. Do you know what that load was? It was because they had adopted British standard codes of practice, and it was snow load. And it hasn't snowed in Singapore, as far as I'm aware, for 1 million years. And so we convinced them to reduce it. The point being, sometimes you have to work around codes, and you have to it is hard work if you want to invent things and you want to innovate. But the great fun is actually finding you can get through the process. I mean, where's the fun in saying, oh, I don't want to do that? Let's have a go.
I think that's a great way to great comment. I'm looking at the time, and I want to throw this back to Kewei to finish up. I apologize. There were a couple of questions we didn't get to, but I think we covered the gist of most of those received. Certainly, I would encourage the participants to reach out to the various panelists. I see that Kewei has added a quiz. I didn't know there was going to be a test on this. That's not fair.
We provide several questions, quiz for participants. So if you are interested to reply to us, please. We will provide those certificates of INBAR to those participants who answer quiz.
Yes.
So thank you.
Yes.
Thank you very much for all the speakers. Today we invited.
Can we take a photo together?
Yes. So my colleague Ms. Jingwei will help to take group photos.
We take a group photo. So many people. Everybody.
Open your video. Thank you.
It will take a while. We have 7 pages, so please keep your smile. Keep your smile. Okay, so Yuchen, can you help me? I will do the photo, and Yuchen will do the photo. We'll see which one is the best. Okay, Dulcie, you're also helping me. 1, 2, 3. 1. Now I'm going to page 2. 1, 2, 3. Page. Oh, I see Junqi. I see Ting Han. I see Javier. Okay, now I'm going to page 3. I'm going to page 3. Ledell, again. Okay, I see so many people. Okay, now I'm going to page 4. Oh, so many people. Page 5. Page 6. Hanan. Sylvia, I saw.
Yes, I'm here. I'm
Page
here.
7 now.
Listening to you guys. Yes.
Okay.
All the way in Jamaica, listening to you while I'm at work.
Thank you for hanging out with us.
Thank you. I'm looking forward to when we can presentation as well.
So thank you so much. We will complete this meeting now. Next week we will have the session 2. We will focus on discussing the recent development of bamboo construction sector in China. So welcome you all to join us in next week. So thank you. Bye. Have a good night.
Next Tuesday. Not next Thursday. Next Tuesday. Okay.
Thank you.
Bye-bye.
Thank you, everybody. Are we going? Are we leaving now?
Don't forget to answer the quiz.
Bye-bye, guys. It's really
Forget to
nice to
send the quiz to
meet
us.
everybody. It was amazing.
Bye.
Neil,
So nice to meet you here.
Neil
Bye.
Thomas, I'd like to mention that there is an bamboo bike in COP26 from in the INBAR pavilion. The fully functional bamboo bike.
And good luck with COP26. Good luck with that.
Yeah.
We're all supporting you totally, absolutely 100%.
Thank you.
Thank you. I'm virtually participating in COP26 from the Philippines.
Yeah, how many of you are joining 26?
So you already have the link for the COP26 side event.
Yes, tomorrow. There's also an INBAR event tomorrow.
Did we put it here in the chat box to share with people?
No, I think COP will not allow us to broadcast from the venue. But you have to register in COP26 platform, and then you can see. Okay.
Okay. Thank you.
Bye-bye.
Thank you.
Okay,
Thank you very much.
take care, everybody.
Thank you.
Bye-bye.
Thank you for this amazing webinar.
Gracias.
Bye.
Gracias por la invitación.
Bye.
Bye, Michael.
Oh, Joey.
Yeah, Nelly.
Joey.
Bye.
Javier.
Bye.
Bye.
Goodbye.
Nandita, bye-bye.
Jen.
I will send the screenshots, Jinwei, Kewei. I will send the screenshots to you.
Yes, thank you. Thank you, Dulcie.
Bye.
Oh, I can't wait. Bye-bye.
Bye-bye.
Bye.
Bye.